Today's video is going to be a second day on completing the square. So we're going to start by reviewing what we talked about yesterday, and we're going to complete the square by creating a perfect square trinomial. And I can see that my setup's not as nice as what we had yesterday, so it's going to get a little more complicated. We want to isolate our a and our b term and create that perfect square c term. So what I need to do is I need to move that 13x over, so I've combined my like terms. So I've got x squared minus 30x, and then I need to move the c value over so I can combine those together, and that's a negative 243. Now what I'm going to do is, once I've got all my pieces in the right spot, we need to take half of our middle term, which is a negative 15. When we square 15, we get 225. So I add 225 to each side. But by doing that, we've created that perfect square trinomial, so when I factor it, it's x minus 15, and we know that if this was a positive number being squared, that would be a plus, but it's a negative, so it's x minus 15 quantity squared. A negative 243 and a positive 225 is a negative 18. Then to get to x inside that quantity, we have to square root each side. We break down 18, 9 and 2, 3 and 3. The square root and the square cancel out, leaving us with x minus 15 on the left-hand side. We had a negative on the inside, so that's a plus or minus a 3i root 2. Now to get x by itself, we move 15 over, and our answer here is going to be x equals 15 plus or minus 3i root 2. Okay, so that's a review of what we talked about yesterday. We are going to step it up just a little bit today, and we're going to talk about what happens if your a value doesn't equal 1. So we always refer to a quadratic in standard form for completing the square. So what if the number with x squared doesn't equal 1? We're going to start the same way. So we're going to move the number over, our c value. So we've got a negative 3x squared plus 24x is equal to 27. And what we're going to do is we're going to pull out. We're going to factor out that a value. So we're going to create the a value to be 1. We're going to make it happen. So when we pull out a negative 3, that becomes a positive x squared. And 24 divided by negative 3 is going to give us a negative 8x. Right? So now we're going to create a perfect square trinomial within the inside. So if the a value is not 1, you're going to make it 1. We take half of the middle term, which is a negative 4, and we square it, which is 16. Now, the only difficult part here is I'm not just going to add 16 to the other side. I have negative 3 of those trinomials. So I have to multiply a negative 3 and a 16 together to get negative 48. Okay, so we simplify what we have. We've got negative 3 on the outside. We factor that out. Our perfect square trinomial, when we factor that, that's x minus 4 quantity squared. On the right-hand side, a positive 27 and a negative 48 is a negative 21. Now we want to solve for x. We have solved for problems like this before. If I want to get to x, I have to isolate the term being squared, so I divide both sides by a negative 3. And we're left with x minus 4 quantity squared on the left, a positive 7 on the right. We square root each side. X minus 4 is equal to plus or minus the square root of 7. When we break down 7, it's just 7 and 1, so I can't pull anything out. And our last step is adding 4 to each side. Alright, so again, to review, if our a value is not 1, we make it 1. So we start the same way. We move our c value to the right-hand side of the equation, leaving us with 4x squared plus 40x on the left and a negative 280 on the right. I'm not going to create a perfect square trinomial yet because my a value is not 1, my a value is 4. So I'm going to pull that 4 out. And when I pull the 4 out, I'm left with x squared plus 10x. And we still got the 280 on the right, so all I've done is pulled out that factor of 4 from those two pieces. Now I'm going to create that perfect square trinomial. Half of 10 is 25. So I add 25. That's creating the perfect square trinomial right there. The only thing that you got to be careful about is when I go to the right hand side, I don't just add 25 like we did yesterday. I have 4 of those 25s because I have 4 of those trinomials. And 4 times 25 gives us 100 on the right. So the left hand side, we've got 4. We factor that perfect square trinomial to x plus 5 quantity squared. A negative 280 and a positive 100 is a negative 180. We want to isolate that squared term, so we divide by 4. And a negative 180 divided by 4 is a negative 45. We want to get to that x, so we unlock it by square rooting each side. X plus 5. We break down 45, that's 9 and 5, 3 and 3. So the 3 goes the outside, the 5 stays over in the inside. Since there was a negative there, it's plus or minus 3i root 5. Subtract the 5, and our final answer is x equals a negative 5 plus or minus 3i root 5. Never forgetting that you actually have two answers there. One when you're adding the 3i root 5, and one when you're subtracting the 3i root 5. Alright, let's turn over to the back page. We can use completing the square for other things besides just solving. Earlier in the chapter, we've talked about how to write an equation in standard form, how to write an equation in vertex form, and how to write an equation in intercept form. We can use completing the square as another method in order to write an equation from standard form to vertex form. Before, I gave you a vertex and I gave you a point, and you had to find the a value. Now what we're going to do is we're going to go from the standard form to the vertex form, so it's going to be easier to graph. And we're going to use the completing the square idea for this. First, we've been talking about standard form a lot, and we know now, it's probably ingrained in your brains, that standard form is ax squared plus bx plus c. We've got to know what we want our equation to look like before we get started. So let's remember that vertex form is y equals a times x minus h quantity squared plus k. So this is what we want to get our equation to look like. And notice how we have that squared quantity in it. Right. There's going to be a couple slight differences than just completing the square, but completing the square is going to be one aspect of this. So we have our y. I'm going to leave some room there. And what I want to do is I'm going to use those two pieces, just like before, the a and the b, to create a perfect square trinomial. The only difference is I'm not going to move that negative 9 over. This time the negative 9 is going to stay on the same side. We're going to use that a and b value to create a perfect square trinomial by taking half of it and squaring it. So I'm going to be adding 1 there. If I add 1 on the right, I've got to add 1 on the left. So this becomes y plus 1 is equal to, we factor the perfect square trinomial that we just created, which is x minus 1 quantity squared minus 9. By completing the square with the a and the b value given to us, I see that I'm very close to my vertex form. The only difference is I want to solve for y, so I move that 1 over, and we get y equals x minus 1 quantity squared minus 10. And then when we look at this, really important here because people always forget this in the quiz, I can tell the vertex from the equation. The vertex is the opposite of the inside, so that's a positive 1, exactly what you see on the outside. So your vertex there is at 1, negative 10. Let's go ahead and do our last problem for our notes today. Again, we want to go from standard form to vertex form. We're going to use that completing the square idea, except for instead of moving the c value over, it's going to stay on the same side. I'm still going to use the a and the b value to create the perfect square trinomial. When I look here, I notice that the a value is not 1. If the a value is not 1, we have to make it 1. So I pull a 2 out, and that leaves us with x squared plus 7x on the inside. We still have that minus 1 over there on the outside. We've got our y over on the left side. We take half of the middle term, and unfortunately it doesn't divide equally, so we keep it as a fraction and we square it. So we're going to add 49 fourths on the right hand side. We want to be careful though, because we have 2 of those trinomials. So on the other side, on the left hand side, I'm going to have 49 fourths times 2, which is really 49 halves. So I've got 2 of those trinomials, so I'm adding 2 of those 49 fourths. Don't freak out just because there's fractions. I know a lot of times when a problem comes up and you have these messy fractions, you just stop and you move on to the next problem. Most of the time, the more difficult the problem is, the more fractions, the weirder it is, the more points it's worth. It's this exact same process, you just have a harder number to deal with here. So we've got y plus 49 halves on the left-hand side equals 2 times, we factor that perfect square trinomial, which is x plus 7 halves, quantity squared. Remember, this is always going to be that term on the inside. Minus 1. Our last step is to isolate our y value. So a negative 1 and a negative 49 halves, we've got to combine those two together to get y equals 2 times the quantity x plus 7 halves squared minus 51 halves. And that is our equation in vertex form. And the vertex form allows us to tell that in this case, our vertex is at a negative 7 halves and a negative 51 halves. So just because it's a fraction doesn't mean anything in your process is going to change. Okay, we are all done for today.